Okay, and welcome to Project 3, where we're going to dive into CAD using Fusion 360. And the type of modeling that we're going to be doing with Fusion 360 is solid modeling. And that's where all of the edges of the model connect to each other to create a closed volume. And we call that closed volume watertight. If there was space between the edges and it didn't connect, we wouldn't be able to mathematically form a closed volume, and that body would not be watertight. So we're going to be doing solid modeling, and because the 3D printing process requires a solid model to slice up to send to the 3D printer, and also a lot of our other engineering analysis tools like CFD or structural analysis require watertight solid models. And this is all as opposed to a very different type of model they call surface modeling, where we don't model the structure as a complete solid. We just model each surface of the structure to kind of create the shape and the look of the object. So surface modeling is much more free-formed. It's really powerful for just rapidly creating surfaces and getting something that represents what you're looking at. But there's no guarantee that those surfaces will all connect to each other and form a watertight model. And if it's not watertight, we won't be able to create a solid model out of it. And we won't be able to 3D print it, and we won't be able to do engineering analysis with it. So we're purely interested in creating solid models. Just a little bit of an introduction to the Fusion 360 interface here. I've got all of my projects over here in my data panel, and you're going to want to click the new project button and create a new project for AE206 probably, where you can do your work inside. I can hide that data panel or bring it back. And I can also right-click on my projects here and do different things with them, one of which is to share a public link. So I can share this public link and send it to somebody, and I can let them download the model, or I can put a password on the model before they download it. So that's a really powerful way to share projects in Fusion 360. And finally, I can invite people to collaborate in this project with me by putting in their email address and sending them an invitation. All of these projects are stored in the cloud, so if I log into Fusion 360 on any other computer, I'll see all of my projects here, and I'll have access to them from any other computer. Now, it'll only let you log into one computer at a time, but it will suspend your session on the other computer while you're logged into your current computer. And across the top here, we've got the title, the tab for our current design. We've got our modeling toolbar here. We can choose between the design tool or rendering our model, which is showing what it would look like in a natural light environment, or creating animations or simulations, or even tool paths for doing subtractive manufacturing. We're going to stay in the design menu, and we've got our design tools here across the top, and we're going to be doing solid modeling. So here's all of our solid modeling tools. We also have surface modeling tools, mesh tools, sheet metal, plastic, and other utilities here that can come in handy. But we're going to be using solid modeling tools. I'll dive more into the actual interface of the model later on, but for right now, I just want to give you an overview of how to control the model. Okay, so you can use your mouse wheel to zoom in and out. If you control where you put the mouse, it's a really easy way to move back and forth on the model to zoom in and out on different things, or you can middle click and drag the model to pan, or you can hold down Shift and push the middle button to rotate the model. And you can change how all of these work by going to Preferences, okay, and going to the pan, zoom, orbits here. And if you're coming from a different program like Inventor, SolidWorks, or Tinkercad, you can choose those conventions, and then your mouse and keyboard will work just like those programs for panning, zooming, and rotating the model. So I've got my octoprism here that I created already. So let's dive in, walk you through how I did this so you can create your own octoprism. Okay, so let's get started. Here's the Project 3 handout, and we're working on part 1 right now, which is just creating our CAD and exporting it for 3D printing. And a basic overview of the shape is we're looking for something that's about 2 inches by 2 inches and about 2 inches high, and we're going to put all those features on it that you just saw: holes, chamfers, fillets, emboss things, and deboss things, and then we're going to save that file for 3D printing. Okay. All right, so I'm back in Fusion. I'm going to hide the data panel here, and now we need to go about creating our CAD model. And the basic overview of the process is we're going to start by drawing a 2-dimensional drawing called a sketch. And then we'll take that sketch and turn it into a 3-dimensional solid model using an extrusion or revolve operation. Once we have that 3-dimensional solid body, then we can use our fillets and chamfers and holes to trim it into the final shape that we want. Okay, so we need to start by creating a sketch. I'm going to turn on the origin so we can see where we're at here. And we have 3 planes that we can create our first sketch on by clicking the sketch button here. And it's best practice to start by creating the sketch on the bottom XY plane with the Z in the up direction, because that's the direction of the Z-axis in the typical 3D printer convention as well. So I'll click on that plane to create a sketch there. And now we really need to strategize on the best way to sketch out an octagon. Obviously an octagon is a shape with 8 sides, so we could just start by choosing the line tool here from the create menu. And there's a lot of other options here on how to create sketch shapes, rectangles, circles, arcs, and there's different ways to draw all of these. But the most basic one is just a straight line tool. And we can just start by trying to draw an octagon with 8 straight lines. And we can try as hard as we can to line up these edges and see how good we get. Now, when I close this shape here by connecting this line back to itself right now, you're going to see it's going to turn a different shade on the inside. And this indicates that I've got a closed sketch, okay? And that's very important because that's the only type of sketch that we can turn into a three-dimensional solid model is a closed sketch. So if you have this and the sketch is not closed, then typically that means that one of these sketch points didn't connect, and we need to go back and connect it. So for example, right now this sketch is not closed, and I couldn't extrude or revolve this into a solid model. Now sometimes you may think you've closed a sketch, but actually the points are very close to each other, but they're not touching each other. So even when you zoom out, the sketch might look as if it's closed. When you zoom in, you may find that it's not closed in one place, and it can be very difficult to find where the sketch is not closed. So a great trick is just to take the line tool and draw a line completely across the sketch. And we can see here that where the line intersects the closed portion of the sketch, it becomes shaded, indicating that that sketch is closed. And I can move this line around to try to narrow down where the sketch is not closed. And so if I do it like this, what I'll figure out is that this entire portion of the sketch and all of the points on this sketch are closed, and the offending point is up here in the part of the sketch that's not closed. So that can be a really useful trick for you to figure out why your sketch isn't closed. But anyway, I have a closed sketch here now, and it looks kind of octagonish, but obviously these sides are not equal length right now, and they may not be parallel to each other either. So I really need a way to enforce some conditions on these lines, like equal length or parallel or etc. And the way we do that is through constraints. Here's the constraints menu up here. Here's all the types of constraints that I can apply to sketches, lines, and points. And the ones I'm interested in right now are equal and parallel. So I'm going to click on the equal constraint and click on the first line and the second line, and the two lines become equal length. Then I can click on the second and the third one, and they become equal length. And I can continue my way around the shape until all the lines have equal length. Okay. Now that looks like a pretty decent octagon. Not bad. I could try to make sure that the sides are parallel by clicking on one side and clicking on the opposite side, which should be parallel, with the parallel constraint. Now when I do that, I get an error that says the sketch geometry is over-constrained. And this is really the drawback of using constraints, is it's really hard to see how they interact. You can see all the icons for all the constraints on all the lines around the sketch, but just by looking at those icons, it's really hard to know right away how those things interact and might conflict with each other. And then when you think you need to apply a constraint, you may not be able to, because you may actually be over-constraining the geometry. Okay, so I need a better way to draw an octagon. So I need to get rid of this one. So I can just select the whole thing and press delete. I'm still in the constraint tool, so I'm going to press escape to get out of the constraint tool. And now select the whole thing to press delete. Now I'm using window selection right now, and window selection works differently when you drag to the right versus dragging to the left. When you drag to the right, it only selects the things that are contained within the selection box. So in this case, I only selected the one line here, and if I press delete, I would only delete that one line. When I drag to the left, it selects any closed sketches that are touching the selection box. So in this case, I get the entire octagon that I've drawn. Okay, and this difference in behavior is absolutely critical when you get to complex sketches or complex bodies and you need to select things a little bit more specifically. Understanding how this selection tool works is very important. So I'm just going to select the whole thing for right now and delete it. And now I'm going to try a second method of creating an octagon. And I'm just going to use the 2-point rectangle tool to create a square. And so I clicked on the first point of the rectangle, and it came up with these two input boxes. The first one's highlighted in blue, and I can type in a number here in millimeters to give that a dimension. I can press tab to go over to the next input box and type in 50 there. And I can zoom out a little bit, and I can press enter, and now I've got a 50 millimeter by 50 millimeter box. and it's a closed sketch because that's what the rectangle tool produces. And I know that it's dimensioned and that all the sides are perpendicular and parallel and everything. Okay, now for this method of creating an octagon, I'm going to copy this square and rotate it at 45 degrees to the first one, and then I should have an octagon left after that. But I need to make sure that both of them are aligned perfectly. So I'm going to create a point, and I'm going to put that point in the center of this box, and that's going to be my alignment point for aligning the two boxes. And now I'm going to use my selection tool to copy this box, and I'm going to press Control-C and Control-V, and now I get a new square here, and I can drag this square over using these position handles here to see that it's the second square. And I can also rotate it using this rotation handle. Now when I start the rotation, you can see the input box that pops up here, and it's highlighted in blue, letting me type in a rotation angle. So I'm going to type in a 45-degree rotation angle and press Enter. And now I've got a second box which is rotated 45 degrees to the first box. Now I want to select the second box. If I were to do the dragging my selection tool to the right, I'd have to actually capture a point on the first box inside of the selection box, and you can see that point that got selected right here. I don't want to do that, so I'm going to drag to the left and select that box that I made, and I'm going to say Modify, Move Copy, and now I can move this thing around. I just need to line it up with the first box, and I can try to do it by hand, look until it looks really close, but then when you zoom in you realize it's not close. Those 2 points aren't on top of each other. So in this case, when I do the move command here, I'm going to use the point-to-point type of moving here that you see over here in the pop-up move dialog box here. So I'm going to click on point-to-point. I'm going to click on my first point, click on my second point, and now these 2 points are lined up exactly. I can zoom in as far as I want, and I'm not going to see any space between those 2 points. Now I can press OK and be done with that move. Now I've got a lot of closed sketches here, and the one on the inside is a really great octagon. I know opposite sides are parallel. I know the sides are equal. This was a really great way to make an octagon, and I could extrude just this shape on the inside of these two squares, and it would probably turn out pretty good. But there's an even easier way. I can delete all this, and I can say Create and use the Polygon tool and use a circumscribed polygon. And I can click on my origin because we always want our CAD models to be centered or as close as possible to the origin. So I'm going to type in 25 millimeters for the radius, and then I'm going to press Tab to get to the second input box, and that's the number 6 there, the number of sides it has. I'm going to type in 8, and now I've got a perfect octagon. So that's probably the easiest way, but the point is, we need to put some thought into our sketches on how we create the sketches, and then some of those tools along the way on how to create the sketches are really, really powerful. Okay, and there's one sketch tool left to talk about, and it's perhaps the most powerful sketch tool of all, and that's the Sketch Dimension tool. I can click on that tool up here, and now I can enforce a dimension on any quantity of the sketch, either a line or between 2 points or anything. I can't do it right now because I've already got a dimension on the sketch, the 25 millimeters that I typed in, so I'm going to press Cancel here, and then click on this 25 millimeter dimension and press Delete. So I remove that dimension, and now I could just drag around any point on the sketch if I wanted to, because there's no dimension enforced on it. So I want to enforce a dimension, so I'm going to click on Sketch Dimension here, and I could click on one line and just type in a dimension like that, and I'd enforce the dimension on just that edge of the octagon. Or I can undo that, and I can click on the dimension tool and click on from one side to the other side, and then enforce a dimension on the overall thing. So I could type in 75 millimeters here. I can place this dimension wherever it's convenient on the sketch, wherever it's readable. I can come back into that dimension and type in a different number. I can even type in different units. So we wanted ours to be about 2 inches by 2 inches. So I could type in 2 inches right here, and that's 50.8 millimeters, and Fusion automatically does the conversion for you. I can do simple math here. So I could say 2 inches times 1.3, and that will result in a 66 millimeter dimension here. The important thing is when you're typing in these things in math that you specify the units so that Fusion knows the units. So I put in inches on the first term there, so Fusion knows the inches. I can do division here. It's a little bit harder. I can type in 4 divided by 3 inches, and it's hard to see, but it's kind of in red right now, showing that Fusion doesn't like it. But I could do 4 times 3 times 1 inches, and now it goes black. and press enter, and it calculates that dimension right there as well. What's even more powerful is that I can create a parameter up here in the modify menu, go to modify, change parameters, and I can add a user parameter here for the diameter of this octagon. So I can come in here and say octagon diameter, and I can use millimeters or use any other type of units here that it has. I'll do inches, and I'll type in 2 inches here, and I'll press OK. All right, so now in this sketch, I can double click on this dimension, erase what's there already, and then type in that parameter that I just named, octagon diameter, and press enter, and it will enforce that number. And later on, I can come back into change parameters here, and I can change the value of this parameter to be 4 inches, and press OK, and the sketch automatically changed because that parameter is tied to that primary sketch dimension. That's a really useful tool when you have a little bit more complicated model where the sketch dimension results in a whole sequence of operations that are dependent on that sketch dimension. You can go back and change that sketch dimension really easily without ever entering the sketch. Anyway, I'm going to go back in and type 2. So there's my original sketch. I've got my sketch dimension here, and this sketch is looking good, and I'm ready to turn it into a solid model. So I press finish sketch there, and now I can kind of just rotate it around a little bit and see the octagon. And now my toolbar up here is showing some ways to create a solid model. And the most common ones are pinned on the toolbar. I can extrude or revolve or loft or use a form. Right now we're going to use an extrusion. I'll just demonstrate a revolving really quick. So I could click the revolve tool. It automatically selected the only closed shape that's in my sketches right now. And now I need to select an axis for the revolving. So it already selected the sketch profile over here. And if I select an axis, I can select any straight line as an axis. So if I selected this axis right there, it would revolve that 360 degrees and create a solid model out of it. And that's what I would be left with right there, which is a really nice looking shape, but it wasn't the octoprism that we wanted. So I'm going to cancel that. And I'm going to use the extrude tool to extrude this. And again, it automatically selected the sketch profile there. And I can just drag this handle up or down to create the octagon, whatever dimension I want. But of course I want it to be about 2 inches high. So in this input box or over here in this input box, I can type in 2 inches. That creates a 2-inch high extrusion and turns this thing into a solid model. There's a lot of different ways to use these tools, and you'll see all those ways over here on the little pop-up menus for the tools. Right now I'm doing a one-sided extrusion. I could do a two-sided extrusion where I extrude it out the other way as well. That can be really powerful sometimes, especially when you're cutting alignment holes in an aircraft or something like that. And I can even taper it as I extrude it, so I could type in 10 degrees here, and it's going to taper it out 10 degrees to create kind of a cone shape. But I'm not going to do any of that right now. I'm just going to extrude it up 2 inches, and the operation that I want to do here is a new body. I don't have any other bodies right now to join or cut or intersect with, so I'm just going to make a new body. So then I press OK, and I've got my three-dimensional solid body of an octoprism. Okay, and this is a good point to pause and dive a little bit deeper into the user interface in Fusion 360. So, of course, I've got my view cube up here, and I could left-click on this and drag this view cube around to rotate the model as I want. Or I could click on any of these faces or edges. So if I click on the back face here, it'll align with that view. Or if I click on the edge of the back, it'll rotate it, or I'll do the corner edge actually. So it looks at it from that diagonal view. Or I can always press the home button. If I get lost, I can always press the home button to get back to the home view. If I'm not sure where I am and the model's kind of far away like that, I can always press this home button to get back to the home, which is really useful. Okay. Over here on the left, I've got my model browser. I can hide it, but generally you don't want to hide this thing. You want to keep it out because this is what you're working on. It says I've not saved my model right now, which is a foul. I'm going to press Control S. I'm going to save it as my octoprism. And it's saving it in the project that I created. So I'll press enter there and save the project. So now my project has a name, my octoprism. There's some overall settings for my model. Right now I'm working in units of millimeters. I can change the units that I'm working in by pressing the edit button and changing everything to inches or feet. But 3D printers are set up to work with millimeters by default. So I'm just going to keep working with millimeters. I've got the origin here. I can toggle visibility of the origin on or off. Usually leave it on until you're pretty much done making the model, or if it's getting in the way, you can turn it off. Now I've just made my first body, and it shows up here under the list of bodies as body 1. And I could rename body 1 by clicking on it twice and then giving it a name. And that can be really useful to keep track of your bodies when you have a CAD file with hundreds of bodies in it, or even dozens of bodies. And then of course I've got the sketches that those bodies are dependent on. And the sketch is automatically turned off when I did the extrusion, so I can click on the eye next to it to toggle visibility back on. I can turn the body off. There's my original sketch. Now moving down to the bottom, I've got my timeline here. The timeline keeps track of the sequence of events required to, basically recreate the CAD model. So the first event was this sketch. The second event was this extrusion. I can right-click on this extrude operation, go to Edit Feature, and I can go back in time and edit this feature to a different height and press OK. And that change will carry forward through any sequence of events that come after this in the timeline. But I'm going to edit feature, and I'm going to go back and type in 2 inches right now. So the timeline is really important, especially when we get further on down the model. You'll see things build up in the timeline. And if you go back and make a change in the past, it can affect the future, just like real life. And then finally, I've got this navigation bar here where I've got some tools to rotate the object. I can click on that, or I can escape to get out of it. I can look at any face, so if I press that look at button, I want to look at this face over here, it would rotate it around to look at that face. And of course I can pan, zoom in, etc. Now display settings is pretty useful. The default is shaded with visible edges. I can just do shaded with no edges, or I could do shaded with hidden edges, where you can actually kind of see through the object and see the other edges that are on the other side of the object. That's really handy sometimes. Or I could do a wireframe model where I'm just looking at the edges of the model. Shaded with visible edges is the most common. Finally here we can turn off snap to grid. If you're having a hard time sketching or aligning something with a certain point on the sketch, you can turn off snap to grid if you're trying to snap it to a different point instead. Okay, so now the handout calls for a hole through the middle, about a 1/2 inch wide. Again, get creative, but there's 2 ways to make a hole. I'm going to click on the hole tool here and click on the top surface. Doesn't necessarily automatically align it with the center, but I can drag it to that center point right there, and then it kind of snaps to that. So now this hole is aligned with the center. The hole is not all the way through. I can drag it all the way through, and then I'll just get a hole through it. And there's a lot of options with the hole tool. Really, the hole tool is set up for making holes for screws or fasteners, which can even be threaded. So the hole tool is a quick and dirty way to make a hole. The other way to make a hole is to make a sketch and make a circle on it and then extrude it. And that's the way that I'm going to do it. It's a little bit more controllable, and we can control the sketch differently. So I'm going to click on the new sketch tool again. Now I could go back and add this on my original sketch, but I'm just going to make it on a separate sketch for now. You want to keep your sketches a little bit clean, not clutter up too many features on the same sketch. So now I'm back in sketch mode, and I clicked on the circle tool here, and by default it's going to create to a center circle where I specified diameter. So I clicked on the center point, and now I can specify a diameter, and I can come in here and type 0.5 inches, and I've got that circle on my sketch. I can press finish sketch, and now I'm going to extrude this sketch feature out into the solid body. And if I look over here in the extrude menu, it's defaulting to a cut operation because it sees that I'm dragging it through a solid body. And I can just drag it up to be plenty high above the object I want to cut. It doesn't matter if I'm cutting too far, and press OK. And then I've got this hole cut out of the center of my octoprism, exactly like we wanted it to be. Okay, and then I want to add some features to the top of my octoprism, some chamfers and fillets. And chamfers and fillets are just different ways of treating corners. It really matters for subtractive manufacturing, where we are machining out a shape. We'd want to put fillets on inside corners so it's easier to machine out, or chamfers or fillets to make things fit together better. In this case, we're just going to do it for aesthetics. So I've got my modify menu here with all the ways that I can modify this body, and I'm going to choose chamfer first. And I'm going to click on the chamfer tool. I'm going to put a chamfer on the outside, and I'm just going to click on any edge to chamfer it. And then I've got an arrow here that lets me pull that edge in and replace it with a flat diagonal face as kind of a transition between the two sides of the shape. And so that's all a chamfer is a flat transition between the two sides, as opposed to a fillet, which is a round transition between two sides of the shape. So there's a fillet shape there, and I can just specify a diameter of the fillet. So I'm going to chamfer the outside edges first, and I'm going to go around my shape and select all of the edges so I can do the chamfer on all of them at the same time. I've got them all selected, and now I can drag my handle in and create my chamfer. Now if I drag my chamfer in far enough, eventually it's going to start to eat away at the other edges in the hole in the middle, and eventually it's going to fail because Fusion can't compute the chamfer anymore. So that's something to watch out for the chamfer and the fillet tools. You want to start with small quantities and slowly work bigger to keep the tool from crashing. And with the chamfer tool here, I'm just using a 45-degree chamfer right now. There's a different kind of chamfer called a two-distance chamfer where I drag each edge independently to control the angle of the chamfer, and this is a really useful chamfer tool in a lot of different situations. I find myself using this one quite a bit. So go ahead and play around with whichever one you want to do. I'll just do an equal distance chamfer for now though, because it looks kind of nice on our octoprism. And once you've got the chamfer the way you like it, go ahead and press OK on the chamfer menu, and that will be applied to the body, and we'll have a new step appear in our timeline down here. That's the chamfer. And now I want to fillet the inside edge, so I'm going to click on the fillet tool, click on the inside edge, and again the fillet tool is really prone to crashing, so I want to start with small amounts and slowly work bigger. Sometimes you use the fillet tool and you only drag it a little bit at the start and it'll crash immediately because it's already too big. So sometimes I'll just start by typing in 0.1 millimeters just to see if I can even get a little bit of a fillet before the tool crashes, and then I'll go to 0.5 and then 1 millimeter. It really depends on your geometry. The geometry we have right here is really not challenging at all for the fillet tool, unless I drag it too big, in which case I will reach a place where the fillet conflicts with the chamfer and the tool can't compute it and it crashes. So I want to avoid that. So I'll just pull the fillet back a little bit, and that's a really nice fillet right there. It's good enough, and I'll press OK. Just gives it a smooth curve to the inside edge of the octoprism. Okay, and now we need to go ahead and add some decorations here to the outside of the octoprism on any of these flat faces. Now I could click the sketch button and start sketching directly on any of these faces. The sketch tool just needs some flat plane to sketch on, and so I could select any of these to start sketching on. So the sketch tool is really handy like that. Now if I do this, the sketch will be tied to this surface, and if I go back and change the chamfer or change something about the body, that change will propagate through to the sketch, or else the sketch will fail. The other way I could do it is by creating a construction plane that the sketch can reside on. And I can create a construction plane by clicking on the offset plane button here, and then I can create a plane here in space and press OK. And now I've got a new addition to my model tree over here, the construction folder, where I've got this plane that shows up. And now this plane it's not really a part of my physical model, it's just a mathematical entity out here that I can do things with, like create a sketch on primarily. These construction planes are really useful. There's a lot of different ways to create construction planes. For example, I can create a plane at an angle, or I can click on any edge and then rotate this plane around to create the plane however I want it to be oriented. Or I can do a construction plane through two edges, where I select the first edge and the second edge, and then I end up with this plane that's intersecting across the body, and I can press OK with that. And now I can use these construction planes for more than just sketching. I can use this one as a splitting tool. So I can come up here to my modify body, click on split body, click the body I want to split, click on the splitting tool, and it's going to use that construction plane as a tool to split this body into two. And now I see in my model browser over here, I've got two bodies. I've got the left side of the octoprism and the right side. I can turn off visibility on one, and I just have a flat face left. So these construction tools here are extremely useful, not just planes, but also axes and points. They can all be different, used different ways for complicated geometry. In this case, with a simple geometry like this, I'm just going to create a sketch on the side of my octoprism by clicking on the side of it. And now I need to go ahead and add some letters on here so I can emboss my name on this. So I'm going to come up here to the Create tool and go to Text. And now I need to draw a box that the text will reside within. Okay. The easiest way to do it is to draw the box aligned with kind of the face or the area that I want the letters to be centered on. In this case, I'll go from corner to corner of my the side of my octoprism. And now I can type in my text into the text window over here, and I'm just going to type in my name. And now I can align it center and middle. And so now the text is aligned in the center of this face, and now when I rotate it, it's rotating it relative to the center. If you create the text box a different way where it's not aligned with the face and you're rotating it and it's not rotating about the center middle point, then it's going to be really hard to control. But I'm just rotating about the center middle point here. So I can put it on its side, and the text is obviously too big, so the way we control the size of the text is by specifying the height. So I'm going to try 7mm height. That's still a little bit too big, and I pressed enter, so I lost the text input box, so I'm going to double click on the text again to get it back. So I'll go 5.5mm. Okay, 5.5mm, that fits on the side of my octagon pretty well, but that only works with the font that I have selected right now, which is Aero. There's a lot of different fonts in Fusion that you can choose from, and I'm going to emboss this text into a feature that's sticking out on the side, and it has to be 3D printed. So you really want to choose a font that's nice and blocky and chunky and could print really well. Choosing a script font like this, it's just not going to print very well, and the CAD could even crash when you try to emboss it or deboss it. Okay, so you want to choose a font that's going to be really clear and easy to print. Arial works really well. A lot of times I use Franklin Gothic Heavy. Franklin Gothic Heavy is really bold and has a lot of straight lines, so it works really well in CAD and for 3D printing. There's a lot of them that work really well though, so feel free to choose a font that you want to use. So I'm going to press OK now, and now I've got my name on the side of the octoprism, and I'm going to press Finish Sketch. And so I can see here in my sketch tree that I've got my third sketch here, and I can label this sketch as my name, and I could label the other ones here too as the octagon, and this one was the center hole, and I accidentally double clicked it, so I'm just going to name it center hole. Okay, so now I need to extrude these letters out and make a three-dimensional feature out of these letters. So I'm going to choose the extrude tool again, and it's selected that whole profile. I don't want that, so I'm going to X out of that, and I'm just going to select the letters. And now when I pull that out, I get the letters extruding out here at the side of my octoprism. Okay, and this is where we need to start to be cognizant of the fact that we are going to 3D print this, okay? And as we'll learn in the 3D printing video, the 3D printer cannot print on thin air. The 3D printer works by extruding out very hot melted plastic, and that melted plastic has to sit on top of something in order to take a shape. So on the bottom of the octoprism itself here, it's going to start to extrude this on the bottom of the 3D printer platter. But when it gets to the first letter here, it's going to try to extrude a bead of plastic along here. And it's not going to be able to extrude it out on thin air, so it's going to require something called supports. And supports take up a lot of printer time, and they use up a lot of filament. And they also require you to remove them after the print is done, and they can affect the quality of the print. So when we're creating this octoprism, we want to be cognizant of the fact that supports are going to be required, and try to minimize those supports to minimize our print time and to make it look as good as possible. And what I've found is that if we emboss or deboss text that's 2mm or less, it can print this without any supports required, because the piece of plastic will just be attached to the main octoprism. It'll stick out far enough. It might droop a little bit the first time, but on the next layer it'll pick right up and it'll be fine. So I'm going to set these letters to be 2mm letters, and I would suggest you do the same to minimize the supports that you need and to create a good octoprism. Again, all we're going for with this first CAD and 3D printing project is something that's easy to print and easy to make here. Okay, so I extruded out 2mm, and I've got some different operations here. I can join it to create new bodies. If I create new bodies, it's going to create 7 new bodies, one for each letter, because none of them are connected. What I really want to do is join this to the main body and press OK. And that way I still just have one body in my model tree over here, and all these letters are joined to it, and it's all one complete solid model. And that's exactly what we need for 3D printing. So we're going to repeat this for the class year, and so you pick any face to do your class year on. I'm going to create a new sketch on this face right here, and I'll just add my year to this face right here. So I'm going to use the text tool again. I'm going to draw my box across the whole face here. I'm going to type in my class year, and I'm going to go alignment center and middle, and then I can rotate this thing 90 degrees, and now I can make my font size a little bit bigger, 10mm, and I'll stick with Arial, but I'll press the bold button just to make it cut in a little bit more. I'm going to deboss this one into the side of the octoprism. So I'll press OK, finish sketch, extrude this. I'm going to deselect that profile, just select the letters, and then I'm going to pull it into the body of the octoprism there, and you can see the outline that will be cut into it. And I have the same situation here, the same challenge with 3D printing as I did with the emboss letters. Mainly when I cut in, I'm going to have an overhang here where the printer is going to need to print on something, and there's going to need to be supports there. So I can avoid those supports if I make these overhangs less than 2 millimeters. So I'll just do it minus 2 millimeters. I'm doing a cut operation here. I press OK. And now I've got my name and my class here in the side of my octoprism, and it's looking great. Okay, so feel free to keep going and adding other things to the sides of your octoprism here. So I'm just going to add a pattern here to this face right here and show you how the pattern works. So I pressed on New Sketch, and I'm going to create, and I'll create a polygon here. And sure, I'll do a 6-sided one, so it kind of looks like a hex bolt or something like that. So now I've got this one sketch profile on this sketch, and I can click on this sketch profile, and then I can create a pattern out of it. So I can create a circular or a rectangular pattern. With a circular pattern, I'm going to select the objects here, and it selected all of those within the selection box that I drew. And so now I need to select a center point. For the circular pattern, it can be any point in the CAD model whatsoever that you can select. So I can select the origin, or I can select any other sketch point. So like here's an intersection point, I'll select that one. And now it popped up with the circular pattern. I can change the number of hexagons I have on this circular pattern. And or I could change the angle that the circular pattern covers. Okay, so I could change the angle back like this, or bring it out like this, okay, or bring it out this way. And then when I press OK, it's going to give me a bunch of hexagons according to that pattern. So that's a circular pattern. I'm going to use a rectangular pattern that'll fit on this rectangular side a little bit better. So I'll go to Create Rectangular Pattern. I'll select the objects that I want to create a pattern out of, and now it gives me 2 move handles here, and I can just drag these down and over to make my rectangular pattern. And of course I can tell it how many rows and columns to make. So if I type in 2 here, it'll give me 2 columns, and if I type in 4, it'll give me 4 rows of these. And I can specify the spacing here. I can just drag it wherever I want. And I also have the option here to suppress some of these. So I can click on the suppress menu, and then all of these have checkboxes on them now, so I could uncheck some of these. And so I remove those ones from the pattern, so I only have these 6 left over. I press OK, and there is 6 hexagons on the side of my octoprism. Those ones look great, and that's good enough to demonstrate a pattern. Draw a pattern on your octoprism, whatever pattern you want, whatever shape you want. Just get some practice in using the pattern tool. It can be pretty powerful. So now I'm going to extrude all of these, and again, if I extrude them 2 millimeters or less, I'm really not going to need support. So I'll just type in 2 millimeters here, and I'll do a join operation. I do want to just demonstrate supports for the sake of demonstrating it when we do this 3D printing project. So I'm going to pull out one of these hexagons to stick out a little bit further than the other ones. So I'm going to use the extrude tool again, and I'm going to click on the face of one of these, and I'm going to pull it out a little bit. So it sticks out more than the rest, and that'll just give me something to support so that I can just demonstrate how supports work when I print this. You don't need to do this on yours, but I'm going to use the join again and press OK. Now I just pulled that one out a little bit more. Another really powerful tool is the press pull tool. The press pull tool, you can click on any face, and then you can pull that or push that face and see how the CAD computes the resulting shape. And in this case, it results in just those 2 edges being angled much differently than the rest. So play around with the press pull tool, pick on any face that you can and pull that tool and just kind of see what happens. All right, so I've got a pattern, and then over on this side, I'm just going to do one last thing here. I'm just going to draw an airplane here, and I'm not actually going to draw an airplane. I'm just going to insert the outline of an airplane by inserting an SVG, which is a scalar vector graphics. I've talked a lot about vector graphics and how powerful they are in this class, and now we'll get to see why they're so powerful. So I'm going to come up here to insert and insert SVG, and now I need to insert it from my computer. Okay, so here's my SVG. It's an SVG of an F16. I'll press open, and here it is right here. But now we can resize this F16 just by dragging on this resize handle right here, and I can rotate it until it's about 90 degrees up. And then I can just drag it around wherever I want with this handle here. And I'm going to drag it right in the middle of my face. And that's actually pretty close to the middle of the face of my octoprism right there. Okay, so this is a scalable vector graphics image. So it is drawing, and it is a complete line. So it's going to form a profile that I can extrude. And the way that I found this SVG was by going to Google Advanced Image Search. and searching for images by keyword and selecting file type SVG. And that's the easiest way to get SVGs off the internet. It's hard to find the actual Google Advanced Image Search, so often I just Google Advanced Image Search and it'll pull up. So I'll press OK here, and there's my closed profile. And I know it's a closed sketch because I can click on it. It's shaded a different color. I'll press Finish Sketch. And now I will extrude that thing 2 millimeters as well. And now I've got a nice F16 on the side of my octoprism. And I can put other stuff on the side of it. Go ahead and have fun with it. Put stuff on the side of your octoprism. You can even put stuff on the chamfered faces up here, create a sketch on that. Okay, there's a couple other tools that are pretty important to demonstrate. One of them is the spline tool. I hadn't really gotten to that yet, so I'm just going to modify the inside of my octoprism by selecting that YZ origin plane right there. It can be hard to select. So right now it's wanting to select everything on the face of the body, but I want to select that origin plane that's inside the body. And so there's a couple ways around this. I could turn off the body real quick and select the origin plane that I want. Or a really handy trick in Fusion 360 is put the mouse over all the stuff and hold down the left mouse button, and it will give you a list of things there that you can select. And I know that I want that YZ face, so I'm going to click on YZ, and now I made a sketch on the YZ face. Okay, so I am sketching on the YZ plane that's cutting through the middle of my body right now. And to show that, I'm just going to rotate the model a little bit, and you can see my sketch plane going through the middle of the octoprism right now. So I'm going to get back to my sketch plane by clicking on left view here, and I'm just going to use the spline tool. Okay, the spline tool is just a really easy way to create a curved line using kind of a piecewise curve function over an area so that you can create a profile over it. And now each of these spline points here you can pull around to adjust, and there's also handles on this spline point so I can adjust the curvature at that point on the spline. Okay. So the spline tool is really useful for creating curved shapes, more freeform curved shapes, okay? And I'm going to use the spline tool like this. I'm just going to use a straight line down the middle to make a profile out of that. And I want to make sure that that profile I just created was a closed profile. So I'm going to turn off the body for a second and then check that out. It is a closed profile. I'm just going to tweak my spline points a little bit like that. There we go. And now I'll press Finish Sketch. Got to turn the body back on. And now I've got this spline kind of in the middle of my body. And I'm just going to demonstrate the Resolve tool again. So I can select that profile that I just made, select the center axis, and now I can revolve this in a cut operation, and it's going to cut out the middle of my octoprism. And it can be hard to see, but if I turn on hidden edges there, I can kind of see inside my octoprism how it's cut out a little bit. So anyway, just an interesting feature, but I wanted to show you how the spline tool works. You don't need to do that on yours, but you can definitely make more freeform curves with the spline tool. Okay, and let's not forget the parameter that we originally put in for the size of the base of the octagon. Let's go back and change that and see what happens to our model. So I'm going to go to Change Parameters, and right now it's set to 2 inches, and let's change it to 3 inches and see what happens. And the whole octagon got bigger. All the sketches were tied to the faces, so when the octoprism got bigger, the sketches all moved out to be on the sides, so it didn't mess up any of the sketches. Just made the base bigger, everything else adapted, and that's really the power of changing parameters. Now if I make it small, I run into issues where my sketches don't fit on the faces anymore, the chamfers are failing, etc., etc., but I don't want to do that, so I'm going to go ahead and make it 2 inches again, and I'll get back my original octoprism. Now, looking down here at my timeline, you see the sequence of operations I did to create this. I can go back to any one of these and right-click on it and edit feature to go back in my timeline. Notice I went back in time. So my F16 isn't there because I made my class year before my F16. And now I can edit this feature, press OK, and that change in the past would carry forward to the future. Okay, so now we're ready to export this thing for 3D printing. And I'm going to hit save, of course, to keep it saved. Right now there's an asterisk next to the name up the top showing I haven't saved it. So I'll press Control S and save it. And now I need to export this for 3D printing. So there's 2 different places I can do that. I can right click on the body here and say Save as Mesh. And that'll just save that particular body as a mesh. And it'll call it octoprism because that's what I've named my body here. Or I can come to the top of my model tree and right click on the whole project and say save as mesh. That's how I prefer to do it, unless you do have one particular body inside the project and you just want to 3D print that particular body. So I'm going to go save as mesh, and now I need to select a format for this mesh. 3MF is the default now, which is great. 3MF is a format that was created by a consortium of 3D printing companies who are trying to improve the 3D printing process, and the file format's a critical part of that. The legacy format is STL. STL has a lot of restrictions with it. It's just a bunch of triangles and vertexes that are saved in a file. The units aren't necessarily saved in the file. It's literally just a bunch of vertexes in a file, and it doesn't carry a whole lot of other useful information. Whereas 3MF can be just the geometry, or it can also be all of our 3D print settings, which we'll see once we get into Prusa Slicer. So I'm going to use 3MF, and I'm going to click on Preview Mesh so you can kind of see how it's going to split this up into a triangular mesh. And you can see all the triangles it's drawing to resolve the curvature of the body that I created. You can see the spline that I put on the inside there. And you can choose the refinement for your triangles here, and usually medium refinement is more than enough. So medium refinement right now still creates a curvature that looks smooth, and I'm sure the result from 3D printing will be fine. If you have a complicated body or a lot of curvature, you want to choose high refinement as long as your file size doesn't get too big, to make sure that you can resolve all the curvature and stuff smoothly in the body. Okay, but there's my mesh right there. I'm going to click OK and save it to a folder on my hard drive. And I'm just going to hit save right here. And now I've got that file ready for 3D printing. I can open up Prusa Slicer. Okay, and here's Prusa Slicer here. I'll show you how to set this up in a future video, but for now I'm just going to drag and drop my octoprism 3MF file that I just exported onto the platter here. And it's ready for slicing, and we'll go through this whole slicing process next time. But here's the geometry I just made in Fusion 360, and it's ready to be sliced and sent to the 3D printer. Okay, just one final note about surface models. I'm going to show you why a surface model really is impossible to print well. And I've got an S117 here that I collected. I'm going to open a previous version of it. I've been trying to repair it and turn it in from a surface model into a solid model, which can be very difficult. Okay, and this is the original model. I think I got this one off of GrabCAD or something. And a lot of those models out there on the internet are surface models because the people aren't necessarily interested in making a model suitable for engineering analysis. They're just trying to get the shape of the model right, and it's really easy to do that with surfaces, and so that's what people do. Okay, but in this case you can see the model is a different color, but you can see holes in the model here where you can actually see inside the model. So I can actually look through the model here and see the other side of the model because there's a big hole in the model here, and so the model is not a solid body. It doesn't have a volume right now. It's just a bunch of surfaces. And you can see through the model here as well. And so we'd say that this model is not watertight because it doesn't form a closed volume. And we could try to repair this model. So I could go to surface modeling here in Fusion, and I could try to stitch some of these surfaces together. And if I'm lucky, I could stitch this whole thing together into a solid model if all of the surfaces lined up. But you can see in this model that all these surfaces don't line up. And so I'd have to actually come in here and patch it and create new surfaces that connect all these edges to try to create a solid model out of this. So it looks like a really great CAD file, but it's really kind of useless for engineering, analysis, or 3D printing because it's not a solid body. Okay, so with that, I hope you were able to create a good octoprism and get it exported for 3D printing, and next time we'll go over how to slice for 3D printing. And I'll see you in class.